Greetings, I'm Jonathan Spear, I'm saving trees, and welcome to Age of Engineering Supershorts. Today, we're going to make a much more efficient power system using the gas-burning generator, with ethylene, which comes from water, hydrogen, and biofuel in a pressurized reaction chamber. Slight problem, the machine that produces hydrogen costs 500 joules per tick. Easy solution, water in an electric centrifuge makes liquid hydrogen and liquid oxygen, and liquid hydrogen can be decondensated into hydrogen in a rotary condensator. Dynamic tank, 2 basic gas tanks, and a pressurized reaction chamber. Also a rotary condensator. 1 electric centrifuge, which I'll place here. I've set the top to yellow and the left to pink, so that I can trash oxygen and store liquid hydrogen. Biofuel will pull from the crusher into the pressurized reaction chamber, into which we'll push water from the top by using our side config on fluids. We'll place our rotary condensator from this side, because decondensating pulls from the right into the left. Finally, we'll fill our condensator with liquid hydrogen. Every 100 millibuckets of ethylene makes over 170,000 joules, for the measly cost of 60 joules per tick. Finally, we need some basic pressurized tubes in order to feed our gas-burning generator. Advanced control circuits can take the place of advanced circuits. 4 generators, 4 windmills, for 2 iron and 1 nickel in-bar. 2 gas turbines, 2 biogas engines, some redstone iron wiring from advanced generators, iron frames, control circuits, and 2 gas turbine controllers, some liquid mercury, which I can get from an arc furnace with mercury ore, 2 electrolytic cores, and 2 gas burning generators. For now, I'm going to auto-eject substrate into this basic drawer. Gas burning generators output their power on the green side, and accept gas anywhere else. Each of these can generate a maximum of 2160 joules per tick. How much they generate actually depends on their burn rate, which depends on how much ethylene is in the generator, but they self-regulate quite nicely. These 2 generators should hopefully keep us going for a while, and this system is fairly expandable. But my future is in reactors. These are very expensive, requiring fusion coils from Tech Reborn. To pull it off, we'll need quite a bit more Mekanism infrastructure. Diamonds in an enrichment chamber make compressed diamonds. I'll set this logistical transporter to aqua, and this to dark aqua, and set a new filter on dark aqua. I'll make a filter in this logistical sorter on aqua, so we can make refined obsidian dust, which I can enrich into compressed obsidian, and export. Enriched alloy can be turned into reinforced alloy, can be turned into atomic alloy. I've been working hard getting the parts for the reactor. I got industrious a couple days ago, and I'm finally working up to the ICB, so I can make a vacuum freezer for tungsten steel. Let's set up an implosion compressor, layer 1, layer 2, layer 3 with the implosion compressor on top. Although it's true the energy flow circuits require a lot of iridium plates, I can use Tech Reborn plates instead of IC2 plates, which can be made with iridium alloy ingots. And as you remember, these iridium ingots can be made from iridium nuggets from shellnonite in an industrial grinder. Could someone please explain to me why this keeps happening when I try to cook bronze? 19 fusion coils. Don't worry that I skipped over that whole recipe. I'm gonna need to make 1 more fusion coil. I already have the last superconductor I need, but they're pretty expensive, requiring 60k helium coolant cells, which require 240 seconds with 16 endstone dust. Elite control circuits require reinforced alloys. I have lots of tungsten ore, and I can arc furnace it into tungsten. 32 neutron reflectors. Beryllium requires emerald dust. 8 thick neutron reflectors. 13 iridium ingots. 1 iridium neutron reflector. 3 iridium alloy ingots. 48 industrial TNT. 3 iridium plates. A highly advanced machine block. Advanced machine casings, nichrome heating coils which require nickel and chrome in the rolling machine, energy flow circuits, a fusion coil, and a fusion reactor. While I've been breeding up to this glacial queen with perfect stats, I've been waiting on the titanium for 76 steel casings. I know there's a moon that has titanium ore, so I've made this shape card quarry, but if somebody could tell me which moon I'm actually looking for, that would be amazing. With this ice shard, I can make a vacuum freezer, which can turn hot tungsten steel into tungsten steel. 4 copper nickel heating coils, and a blast furnace. The blast furnace requires 36 either reinforced or advanced machine casings. Advanced machine casings raise the temperature. To get the required 3000 heat for tungsten steel, I need 21 advanced machine casings and 15 reinforced machine casings, 5 highly advanced machine blocks, 21 advanced machine casings. The 36 blocks can be arranged in any way you want as long as they're stacked in a 3x3x4 cuboid. 1 tungsten and 1 steel makes 1 tungsten steel. Hot, that is. The vacuum freezer will take care of the cooling process. 76 reactor frames. The reactor controller needs an ultimate energy cube which stores 128 million joules. But to start the reactor, I need 2 billion joules. To store that much energy, I'll need an Energized Induction Matrix. The matrix is a cuboid structure with induction casings for edges, and either induction ports or induction casings for the faces. Inside the multi-block, you can put cells and providers. 6 basic energy cubes, 1 advanced energy cube, 2 basic induction cells, 4 basic induction providers. 1 advanced induction provider. Cells store energy, while providers let you transfer it. Layer 1. Layer 2. Layer 3. Note, the order does not matter at all. Induction ports to transfer energy. Layer 4. Layer 5. If I fill up 3 of these ultimate gas tanks, I'll have enough ethylene to start the fusion reactor. You can use the configurator and energy mode to switch the induction port transfer mode to output. Like I said, the gas burning generator is auto-throttling. It is of special note that at the current speed, it will only take 8 hours to start the fusion reactor. I do not intend to wait that long. Until the next episode, I'll be working on increasing my power production. But in the next episode, I'll set up all the infrastructure required for DT fuel. Anyway, that's it for today's episode. As always, if you have any feedback, I'd love to hear it. I hope you enjoyed!